So first of all, can you tell me why did you do just the Laplace transform of cos bt?
Because then I could use the EAT thing, right? The property when something is already, we know the Laplace transform of EAT. So I just put wherever there is S, I put S minus A.
That, okay. So see, this is the first problem. First of all, you see there is a minus sign over here.
Yeah.
What does this minus sign mean? They are not multiplied.
Oh, okay. It's a linear, this thing.
Yes. Okay. So the entire thing is actually division by t property.
Okay.
Okay. So you do not do the e raised to 80. There is no first shifting of property over here. You have two separate terms which you will use the linearity. You will solve for that, and then you will do the integral part, that is division by t.
Okay. So do I split it into two and then solve like
yeah,
both
you
of them?
split it into two. Like e raised to 80 is 1 and cos bt is 1. You do it e raised to 80 minus cos bt. Okay. So that will be e raised to 80 is 1 by s minus a.
I think so, yeah.
Yes. So 1 by s minus a. Let me put it over here so that we are clear.
Yeah, e raised to 80 is 1 by s minus a.
So Laplace of e raised to 80 will be equal to 1 upon bracket s minus a. Is that correct? And you have Laplace transform of cos bt. Correct?
That's s upon s square plus b square.
Is that correct? So now you have Laplace transform of, you can put it in bracket, and that will be equal to and you do not have to simplify this because you have two separate things. Now you can apply the integral thing, that is division by t property. Okay.
Yeah.
And when you apply the division by t property, it will be, you will have 1 by s minus a, integral of 1 minus s 1 by s minus a, which will be with the limits s to infinity. I think it's s to infinity. 1 second.
S to infinity, yes sir.
Yeah, it's s to infinity. So what will happen is when you put so 1 by s minus a is log of s minus a.
Yeah.
Correct, right? Yeah. So log of s minus a, and you will put infinity first, log of infinity. Okay, I'm not sure, you can leave it as it is. You can do this as, you can take as common. How does it work? Yeah, you will have to, this will have to be figured out properly. Like you can't take it as directly log of s minus a maybe. And this one is also going to be log of something. Or maybe you'll have to do both log, and then you'll have to take it in a form where you are dividing by s, and then you substitute, so that whenever you put infinity it becomes 0, and whenever you put s you keep it as it is, and then you simplify.
Got it.
Got it? Like similar to the example that you had over here. You divide it by s. S is in the denominator, or the power of s is in the denominator. You'll have to do it similar to this. Okay, and then whenever you put infinity it becomes 0, and that's how it will be. Okay, is that clear?
Yes sir.
Okay, fine. But I still want you to, like, whatever you have solved, I want you to send me the scan of all the 15 questions, remaining ones that you have, or even like this one also. Now that you have understood, solve it step by step. As I said, wherever you are applying a formula, mention the formula as well.
Yes sir.
Okay, fine. So today, as per the schedule, we have completed till slide 40, and now we are going to do this slide 40. Now we are going to start with the slide 41. So there is no doubt solving today. We have completed the doubt solving. But if in case after you send me, if I find anything, I will tell you that okay, this so and so particular step is not correct, and that's where you need to do the changes. And I want to go through it. Okay, so that similar to the formula sheets where I found mistakes, if I find mistakes, so that I can correct it. Okay.
Yes sir.
Fine. Okay, let's proceed to the 41st slide. Let's begin. And at the end of the class, we will discuss when we can go for the next class, and what else, what preparation needs to be done. Okay, fine. So Laplace transform of periodic functions. A function f of t is said to be a periodic function of period t greater than 0 if f of t plus t is equal to f of t. Now this is a pretty simple statement. I hope you understand. If the function value, okay, is repeating after a certain time period. Just to tell you an example, you have a sunrise. Okay, the sunrise happens after 24 hours again. The sunrise happens after 24 hours again. So, and the sun goes in the same same path, and the sunset happens after 24 hours. Correct? So you can say that it's a periodic function. The path of the sun,
like the sine function, right?
Yeah, like a sine function. You can say sine function. So I was just giving you the sun, the path of sun.
Yeah, no, I understand.
Yeah, but yeah, as you said, sine function is a periodic function, or any trigonometric function for that matter is a periodic function. It repeats after a certain what do you say, angle in case of that. But this is a period Okay, when you say period, it's over here. When we say t, it's basically time. But okay, what you're saying is also
Time.
correct. So you understand what a periodic function is. And in this
Yes.
particular case, it does not just repeat after one period of time, but it repeats. So ft plus t, again, when you put ft plus 2t, it will be same as f of t plus t. That means it repeats after every n times t, where n is
Yeah.
a integer, okay, and a positive integer. So 0, 1, 2. It can be negative as well, but let's focus on only the positive side for the moment. So 0, 1, 2. So sine t and cos t are periodic functions of period 2 pi. Correct?
Yeah.
So far so good. Any doubts?
Yeah. No.
Over here again, instead of 2 pi, you can also write as 2n pi or n into 2 pi. Okay?
Yeah.
Let's proceed further. So if a function f of t is periodic with period t, then Laplace transform of that function is given as 1 over 1 minus e raised to minus st integral 0 to t e raised to minus ft dt. Now you understand that over here in a Laplace transform, it's usually infinity.
Yeah.
Correct? Now because you are
As to
changing the
infinity,
limits, okay, what is happening? You know 0 to t is the integral value, whatever it is, will be the same as t to 2t, 3 to 3t,
Yeah.
t to 2t, 2t to 3t, 3t to 4t. The integral value will remain the same because it is periodic.
Yeah.
Okay, and therefore those cycles where it is going to multiply by something, okay, that multiplication is basically put as 1 upon 1 minus e raised to minus st. Does that make sense? Now
Yeah.
if you see this is a capital T, so this is basically your period.
Yeah.
Okay, that means this is actually a constant. It is not a variable.
Okay. Yeah.
Do you understand it? It's not your variable
Yes, sir.
small t. It's basically a time period which is coming over here. Okay.
Yeah. It
So
won't change.
it won't change. That's correct. It won't change. So that is the Laplace transform of a function which is periodic. Okay, where the periodic with the period t. So if you know the period with which the function is repeating, okay, and if you know that function is repeating, then instead of applying the usual Laplace transform, you can simply change it to this particular formula. You can apply this particular formula. Is this
Yeah.
clear?
Yes, sir.
Okay. Shall we proceed further?
Yeah.
Okay. So let's look over here. Now, obviously, not just sine and cos, but there can be any type of a periodic function. It's just that you have to understand
Yeah.
whether it is repeating. Okay. So if you look at over
Yeah.
here, from 0 to a, okay, whenever t is from 0 to a, the value is 1. And
Yeah.
from a to 2a, it becomes minus 1.
-1.
Correct? And
Yeah.
the time period is when it repeats. So it started at 0, it again starts at the same value at 2a. So you can say that the time period is
Yeah.
actually 2a.
2a.
Correct? And now since we know that it's a periodic function with a period of 2a, we can apply the Laplace transform for a periodic function. So how does it become? Over here, t becomes 2a.
2a.
T becomes 2a, and this t also becomes 2a, and then f of t. F of t, you will keep it as f of t, but you will then, because this is 2a, okay, you will split the function.
Yeah.
So 0 to 2a, you will split it from
Okay.
0 to a, where f of t will be 1, and
1.
from a to 2a, f
And
of t
then
becomes minus 1.
-1.
Okay, so that's what is becoming. Over here,
Yeah.
t is substituted by 2a. You have 2a as your time period in the upper integral. You split the integrals, as I mentioned. You substitute the value of f of t, 1 and minus 1. And now this integral is simple e raised to minus st dt.
Yeah.
Right? And what is the integral of e raised to ax? E raised to ax dx. It's e raised to ax upon a. Am I correct? Do you have the formula for integral e raised to ax?
Yeah. I'm just checking.
It's not there in the formula
It's
sheet.
1 upon a. It's 1 upon a e to the power ax plus c.
Correct. So we will not have a plus c because it's a integral with limits. And over here,
Yeah.
the
Limits.
value
So
of a is actually s.
yeah. So s instead of a.
Correct. Sorry, not s. It will be minus s. Sorry, my bad. The constant is minus s over here. So 1 over minus s into e raised to minus st.
E to the power. Yeah. Minus st.
And then you will substitute t as upper limit a and lower limit 0. Okay. This particular step, from this to this particular step, you will have to solve it. So what they have done, I'll just tell you. This one, okay, this is basically 1 is actually 1 square, and
Yes.
e raised to minus 2s is e raised to minus as the whole square.
Yeah.
So that's
So
basically
they
a
have
square minus b square.
a square minus b square.
Correct. And they have
Okay.
used a minus
So
b
a plus
into.
b into a minus b.
Correct. So that's why you have 1 minus e raised to minus as and into 1 plus e raised to minus as. Okay. Whereas the numerator part, they have not simplified it. Okay. So let me simplify that for you. So you had the integral of e raised to minus st. So we know it is 1 over bracket minus s multiplied by e raised to bracket minus st. Is that correct? And since you're going to
Yeah.
apply the limits, now that is 1 upon minus s is a constant, so I'll leave it as it is. I'll put a bracket. You'll first put a, and then you'll subtract e raised to that's s into 0, that is 0. Is this clear?
Yeah.
The next step, let's do the next step as well. It is minus 1, okay, and again it is e raised to minus st. So minus 1 into 1 upon minus s, so that becomes plus 1 over s. There are two negatives, right?
Yeah.
1 over s, and then you multiply it by e raised to minus st will be e raised to minus st again, and now you can apply the limits. The upper limit is 2a, so it becomes e raised to, it's minus st,
S to
so
the power.
minus 2as.
Yeah.
Minus the lower limit is a, so e raised to
Is-
minus as. So far so good. I'll write this as as well.
So shouldn't the limits be 0 to a?
0 to a was for the first one.
Yeah. Okay, we're doing the second one. Got it.
The second one is 2a, a to 2a.
To a to 2a. Yeah.
Okay, so far so good.
Yeah.
Okay, I'm not writing the denominator. I'm not writing this particular aspect because we are clear that this is written as this.
Yeah.
Okay, now
Yeah.
this s, okay, this s, if you look
That's
at,
from the first ones, right?
we have s is in both of them.
Yeah.
So I can ignore the denominator for the moment because I have s in both of them, but there will be a minus sign. Sorry, there will be a minus sign from the first term. Is that clear? Not clear?
Yeah.
I'll just put it 1 second. Yeah. So as you see, it is 1 over minus s over here. So I'll remove 1 over s, and the minus sign remains as it is.
Got it.
Okay. And in the second term, I can remove 1 over s again, and that s in the denominator is now clear. Okay. So now we can remove the brackets. So first term becomes negative. Okay. The second term becomes minus of minus, which is plus. E raised to 0 becomes 1. Correct?
Yeah.
Sorry. Delete. This is what is left now. So you see e raised to minus 2as. This first term and the last term is the same.
Yeah.
So I can simply
And
write
it's
it as 2 into.
quadratic equation also.
Correct. And that plus 1, I can put it at the end. So this becomes, you can write e raised to minus as minus 1, or you can write 1 minus e raised to minus as. Okay, the whole square.
Yeah.
And that is what is written over here.
Yeah.
So that particular step, they have skipped it, but now you're clear how they have come to this particular step.
Yes, sir.
Okay. I want you to write it step by step whenever you're doing, so that whoever is checking your paper has no issue in understanding what has happened. Even if you are taking 10 steps to reach to your answer, that is fine. Then writing it in one step and not getting marks for it.
Yeah, I don't even think it's possible for me to
But
immediately figure
yeah,
this
so
part out.
at this point in your slide, I'm not sure how they can come from this particular step to this particular step in one step.
Yeah.
That's not possible.
Yeah.
Okay. In fact, even when I am writing it, I took nearly 3 steps, at least 3 steps, and that is where I have not put in the final thing with the limits, then applying the limits, etc. So
Yeah.
okay, so it is at least a 3-4 step away, and I want you to write those 3-4 steps in your answers as well. Okay, and
Yes, sir.
let's proceed further. The reason it is written in this way, okay, and not the other way, you could have written it as e raised to minus as minus 1 as well. You remember that, you understand that, but it's written this way so that
Yes.
it can be cancelled. You see, this can get cancelled now.
Oh yeah, same term.
Yes. Okay, and therefore you come to this particular answer. 1 power is cancelled basically. It's a square over here.
Yeah.
So 1 power gets cancelled, and therefore you are left with this as your final answer.
Yeah.
Is the solution clear?
Yes, sir.
Okay. Let's move on to the next question. Oh, they've gone even further. Oh, okay. They've gone even further. Okay, and they have converted into a hyperbolic tan function.
Tan function.
Okay. Do you? Okay, I think the hyperbolic functions is definitely not a part of your state 12th board syllabus. I think it was a part of your
No,
first semester. So do you remember these formulae?
Actually, no, so we haven't done hyperbolic in first sem either.
Are you sure?
Yeah.
So was it a part of your current semester?
No, so we didn't have hyperbolic functions, sine functions at all. That's why I was so confused when you brought it up last class.
1 second. 1 second. This is your unit 1. So obviously unit 1 is differential calculus. I don't see this happening this having your hyperbolic. Control F. Just a second. I'm just checking if hyperbolic is there. Because if it is not there in your first semester, and if it is not there in your second semester, any of the units, then I'm not sure uh, how they are giving you the formula directly. It is not a part of solid geometry as what I understand.
Then we have multiple integrals, which again does not involve them.
No.
Beta gamma also does not
Yes.
involve them.
Correct.
And the last, it does? Oh.
No,
And the last one is infinite series.
Infinite series might have it, but again, like it is not where hyperbolic functions will be introduced.
Introduced.
Yeah. So the
If you want,
infinite
I can
series,
tell you
infinite series might have
then one.
hyperbolic functions, but this is not where it will be introduced as per me. You may have.
I can tell you our Sem 1 topics also if you want.
Yeah, do share it with me because like it's been quite some time since I did my own engineering. I'm a mechanical engineer, by the way.
Yes, sir.
But
yeah.
sorry.
So we had differential equations as a first this thing in Sem 1, followed by matrices. Then we had numerical methods, and we had vector spaces.
Okay. So either they skipped it, I'm not sure. Like do.
So I don't think the PDF is like our college's PDF. It's just they pick up the sums from some textbook and they copy paste it. And
who found this PDF? Can I ask you? Like, was it sent by you or? I don't know. That's why I'm asking.
No. This is our official PDF that is sent to all of us, like every single
from
person
college.
in that semester.
From college.
Yeah, from our college.
Okay, fine. So this
is what they teach from in class also.
Okay, understood. Fine. Do you also have a syllabus copy?
Yeah, I think we get a course handout at the start. I do have that also.
If you have it tomorrow, not right now, not after the class because it's late, I know. Tomorrow, do send me the syllabus copy of Maths 1 and Maths 2 as well.
Yes, sir.
Okay, fine. Okay, let's continue with the class. So this is the formula. So yesterday we did hyperbolic sine and hyperbolic cos as well in the initial part, correct? While we were doing the Laplace transforms. So this is the formula. So what they have done is they have just divided the numerator as well as the denominator by this particular term. So when you divide it by 2, it's half. So that half has come over here. Okay. And when you do 1 over this particular aspect, it goes to the numerator and the power becomes positive. So it becomes e raised to as by 2. Whereas over here it's minus as and this gets added to the numerator. So this becomes this overall it reduces. That's how you finally arrive at this particular thing. Now the numerator with the minus sign becomes this hyperbolic sign, whereas the denominator with the plus becomes the hyperbolic cos. Okay. There should not be any space over here between s and h. Okay, just for your reference. And sine over cos is usually tan, and therefore the hyperbolic sine upon hyperbolic cos becomes the hyperbolic tan. And I believe this is the end of the answer. Yes, it is. Is this clear?
Yes, sir.
Okay. Now, apparently, if they have not taught you hyperbolic functions, then I would have recommended that you can leave it over here. But as per the handout given by your college, it seems that they do expect it to be brought till the hyperbolic functions.
So I just have to divide by that specific term.
Yes.
To get the hyperbolic function.
Correct. So you have to understand that hyperbolic sign is basically this. Okay. And whatever is coming inside the bracket of hyperbolic sign is the power of e, which is positive here, which is negative here, and a minus sign in between. Whereas the same thing, same power, not the same power, but the same number if it is over here, and if it is negative over here with a plus sign in between, then it becomes hyperbolic cos of that number. And obviously, sin theta by cos theta is tan theta. So that's what they have done.
Same principle.
Yes. Okay.
Yeah.
Let's move on to the next one. Obtain the Laplace transform of f of t is equal to kt over t, where apparently the capital T is a constant, and it says t is between 0 to t, and they have mentioned that it is a repetitive or a periodic function with a period of capital T. Now they have already given this, so they have given you the answer, which means you have to do this as
solve the question.
Homework. Okay, page number 46. Let me note it down. Let's move on to the next one. Find the Laplace transform of half wave rectified sine wave defined as, so you have sine, I think it's omega, so sine omega t between 0 to pi by omega, then it is 0 from pi by omega to 2 pi by omega, and then it repeats again with a period of 2 pi by omega. Also sketch the graph of the function. Now, if there was, let's say that omega is 1, then it would have been simple 0 to pi, pi to 2 pi 0, then 2 pi to, this will be 3 pi, and so on and so forth, correct? Now, because you have an omega over here, therefore the period, instead of simple pi, it has become pi by omega, and now it repeats the same thing as it would have done for 0 to pi.
Yeah.
And from pi to 2 pi, it is going to be 0. So it is, instead of pi to 2 pi, it is pi by omega to 2 pi by omega. Okay.
Yeah.
So sketch the graph of the function. The graph is already sketched for you. Okay. Now over here it says f of t. Can you tell me what's the maximum value? What's the maximum value of the function?
Is it no, the is it half of pi by omega?
You're telling me the function value or the angle value?
The angle value.
Yeah, the angle value is correct, half of pi by omega. But what is the function value?
I'm not sure.
So you're saying, okay, I'm not able to draw. You're saying that this is the angle where it is maximum. Am I correct?
Yeah.
Okay.
Yeah.
And you told me it is half of pi by omega, which is correct. Okay. The angle you mentioned is correct. Now, can you tell me what is the value at that? What is the function value at that angle?
Oh, is it f of t?
No, f of t is the function, right?
Function, yeah.
It's not a value. I need the value.
Okay.
Like the value at the bottom is 0, as mentioned over here.
Yeah.
So what is the value over here?
Is it 1?
Yeah, it is 1. That's correct. The maximum value of a sine function is 1.
1, yeah.
Correct? Even if you substitute over here in the place of t, if you put half into pi by omega, you get pi by 2. Am I correct?
Yeah.
And sine pi by 2 is 1. Is it clear?
1.
Okay.
Yep.
Now I'm not sure if they have given the solution. So you can simply do the periodic transform. Okay, from 0 to t, it will be 0 to 2 pi by omega. That 2 pi by omega is mentioned over here as well. And then you split the integral. Split the integral from 0 to pi by omega and pi by omega to 2 pi by omega. Now pi by omega to 2 pi by omega, that is over here, the function value is 0. So the integral value will also be 0.
Okay.
And therefore you have a plus 0 directly.
Yeah.
Okay, and now you have only 0 to pi by omega to solve for. Now again over here, it's e raised to minus st sine omega t dt. Now they have given you, they have not given you, but do you know this particular formula?
Yeah, no.
You don't know this. Okay, I think it's integration by parts. Okay, I'll have to check this one. Okay,
Okay.
This is e raised to at is what is it? Exponential, and sine bt is trigonometric.
Yeah.
So you can see if you can apply integration by parts and see if you can come to this particular equation. I can also check your formula list if it is given, because what I saw in your formula list is, one second.
Yeah.
What I saw in your formula list is, it is giving you the basic formulae for the derivatives and integration, but it does not provide you the detailed ones. Like when you have, instead of e raised to x, if it is e raised to ax, I did not see that.
Yeah, but that's you just divide by a, right?
Yes, that's correct. Difficult integral formula.
Actually, the actual formula sheet that we get while we're giving the exam has much more details, like a lot of other stuff also. I don't understand why they just don't give us that as a practice, this thing also.
Okay.
So a lot of stuff like the linear property, the shifting property and all, it's usually, okay, maybe not the shifting property, but linear property, that stuff and all is usually given in the
understood
formula sheet.
So okay, you can probably do this integration by parts separately. Okay, just note down slide 48 and just note that you have to, like, this is an additional homework I'm giving you. Okay, that this is an integration by parts. Just check that you're able to get to this particular formula.
Got it. Yes, sir.
Okay, slide 48, I'll just mention over here. 48, integration by parts formula derivation. Okay.
Yep.
That's slide 48. So they have simply applied this particular formula on this particular this thing, and then they have applied the limits as well, and then they have arrived at this particular answer. Okay, so they have skipped a lot of steps over here. Understood?
Yeah.
If you are able to derive this, okay, then you can even continue and see that you arrive at this particular answer.
Yep.
Okay, once you arrive at this particular answer, what has happened is, you see this is in the form a square minus b square, the second term in the denominator.
Yeah.
Okay. 1 square minus e raised to minus s pi by omega the whole square.
Yeah.
Similar to what we saw in the previous problem.
Yeah.
Okay. And So you'll have a minus
The upper term will get cancelled.
upper term will get cancelled. That's correct, and you are left with only 1 minus e raised to the single power minus s pi by omega.
Yeah.
Okay, so that's how, like, from this to this is clear, but from this particular point to directly this, it's not very clear.
Yeah.
Okay, and with the application of limits, more importantly, they have not just did 2-3 things together, but made it slightly more confusing. So it is better that you try to do this step to this step on your own at least once and verify that you are getting that particular answer. Okay. Next is 49. Again, over here, you are given a periodic function and you have to find the Laplace transform. So this is a homework. Slide number 49. Let's move on to the next one. Unit step heavy side function. Okay. So in many engineering problems, we deal with the important discontinuous function u into t minus a. Okay. Okay. So what you have to understand is, in your 12th standard, while you are studying differentiation, you probably understand continuity and discontinuity.
Yeah.
Okay. So continuity is where it's not just that the function values are same when you are arriving from both sides of the function, but also the differentiation value or the tangent slope when you are coming from both sides will also be the same. That is what is called continuity.
Yeah.
Correct. Whereas discontinuous means the values are different. Basically, it can be discontinuity of the value not matching, or it can be the discontinuity of the slope not matching. Okay, that is what is discontinuous. So in this particular case, as you see, if t is less than a, the value was 0, and suddenly when t is equal to a or greater than a, the value becomes 1. So this is a discontinuity. Even one of the function that we saw earlier, not this one, but the problem that we solved, this one can also be called as a discontinuity, because it was 1 till a, till less than a, and suddenly at a, okay, it changes, it goes to -1. Okay, so at the junction a, it's, you can't say if it is 1 or if it is -1 or it is 0. Is that clear?
Yeah.
Okay, so that's what is a discontinuity, and this focuses on that discontinuity, how exactly the Laplace transform will work in this particular case. So a is a positive constant over here, basically that particular point where your discontinuity is existing. Okay, this function is known as unit step function. Why it is called unit step? Because the function value is changing from 0 to 1 directly. Okay, which is a change of a unit, which is a jump of a step. It's like, it looks like from 0 it is coming directly to 1, so it looks like a step. That's why it is called a unit step function. Is this clear?
Yeah.
So when you look at the graph, you will probably get an understanding. It is also denoted by h of t minus a by alpha t minus a. Okay, now let's look at the function. So see, this is how it happens. It was 0 up to a certain point, then suddenly it became a 1, correct? And if you look at the red step or the graph, it is like a step, and that step is of the height unit, because the value is 1 now, and therefore it is called a unit step. Is this clear?
Yeah.
Okay. So how does the Laplace transform of this step function work? So what happens now when you apply the Laplace transform? You clearly come to this particular thing, e raised 0 to infinity e raised to minus st into the function and dt. Now the value, sorry, what's happened? Sorry, just click. So as you see, it directly gives you e raised to minus as over s. 1 second, why did it give you the answer? Okay. So this, they have given you the answer directly, but the reason behind giving you this answer directly is they have used second shifting property. Okay, this is something not correct. 1 second. Okay, they have not given you the proof over here. Okay, the proof would have been something like this. You know what the step function is, correct? You know when it is less than a, it is 0, correct? When
Yeah.
it is less than a, it is 0, and when it is a or more, it becomes 1. So this particular integral, okay, you can split it from 0 to a and a to infinity.
Okay.
From 0 to a, this value is 0,
Yeah.
and therefore the integral value will be 0.
Yeah.
Okay, now that means you are only looking at the integral from a to infinity.
A to infinity. Yeah.
So when you're doing a to infinity, 1 second, and the integral value, this value becomes 1, so you're only left with e raised to minus st dt. This value becomes 1, right? From a to infinity.
Yes.
So it's only
A
e raised
to
to minus st dt,
infinity. Yeah.
which is e raised to minus st over minus s. and then it's only e raised to minus ht. So you get e raised to minus ht actually becomes negative infinity because s is positive, and you have minus of e raised to minus st, which is minus as. Now this e raised to minus infinity actually becomes 0, and this negative over here and this negative over here actually cancel. So you are left with e raised to minus as upon s. Is this clear?
Yes, sir.
Okay, they have not given this particular proof, but I hope you understand how you get to the answer.
Yeah.
Okay. Now that you have understood how the Heaviside function works, now we look at how you can use this in your second shifting property. Okay. Now what is the second shifting property?
Yeah.
The second shifting property says if you have a function, okay,
Yeah.
not f of t, but f of t minus a. Okay, if you have a function f of t minus a along with a Heaviside function ut minus a, okay, multiplied. If you have a function t minus a multiplied by the Heaviside function, it is as good as you are multiplying e raised to minus as to the Laplace transform of f of t. See, this t minus a over here, you have the same Heaviside function with the same minus a value, okay, multiplied with the function that is equivalent to e raised to minus as multiplied to the Laplace transform of f of t. Does this, I wouldn't say it makes sense, but because you have not proved it, but this is the formula. Have you understood this?
Okay, so sir, it's two different functions, but we have what's inside the functions is the same.
That's correct. So you remember in the first shifting, wherever it was s, we used to change
Yeah.
it by s minus a or s plus a.
Yeah.
When the function was multiplied by e raised to 80 or e raised to minus 80.
Yeah.
That's what was the first shifting property.
Yeah.
Correct? In this case, what's
Yeah.
happening is the function is not in terms of t, but it's already in terms of t minus a. And the function is
Yeah.
getting multiplied by a Heaviside function at the same value a.
Yeah.
That
Okay.
is when you can apply this particular shifting property.
Okay, so our first function is just a normal function, and the second function becomes is the Heaviside function.
Yeah, this is the Heaviside function, u into t minus a.
Okay, so we'll always have one normal function and one Heaviside function.
Correct. Now understand this. Understand. The Heaviside function will not be written as it is. Okay? It will not be
Okay.
written as into u of t minus a. It won't be written it this way. What it will happen is, whatever function you will look at, you will see the function having some kind of a step property.
Okay.
And you will understand it is as good as multiplying by the Heaviside function.
Got it.
Okay? You will see a normal function, but you will see that it is having some kind of a step, which means it is multiplied by a Heaviside function. And then you will understand, okay, this is where I need to apply the second shifting property. Does it make sense?
Yeah.
Okay. Now let's
Yes.
look at how exactly we will be applying this particular property. Let's look at it. So you have f of t, which is f1 some function when less than equal to a, and some other function when it is greater than a. Okay. So what's happening? You are writing this entire function. Okay. This is a split, right? The function is a split.
Yeah.
There is some kind of a step happening over here. Okay. It is not a unit step, but you can write this with the Heaviside function like this. Now see what happens when it is less than a. Correct? When
Yeah.
it is less than a, what is the value of the Heaviside function? 0.
When it's less than a, 0.
Correct? That means
Yeah.
this term becomes 0,
Yes.
less than a, and that means this entire thing becomes 0,
Yeah.
which means you get
Yeah.
f1 of t when it is less than a.
Yeah.
Okay. Now there seems to be some mistake. The equal to sign should not have been over here. It should have been over here actually. The equal to sign. There seems to be
Greater than equal to a.
Yeah, it had to be greater than equal to rather than equal to on top. Now what happens? Because in the Heaviside function it's equal to is on the second step according to me. Yeah, it's over here. Correct? So let's assume that you have touched a, or you have gone greater than a. Then what happens? This value becomes 1.
T minus a. Yeah.
The Heaviside function becomes 1, which means it becomes this plus this minus this, and the first term and the last term will get cancelled. And greater than
Yeah,
a,
plus minus.
and greater than a, it becomes only f2t, which is what you have over here.
Yeah.
Okay, so you understand that the function which is mentioned in the question will never be in the form of this. This will be written by
Got
you.
it. Yeah.
Okay, same way, even if it is, this was 2 over here, even if it is 3, even it is 4 or 5, you will be writing it in a similar way as you see over here.
So first is for the first function, then you find the difference between two functions multiplied by u into t minus a.
It's
Then
a1
the
over here.
third function subtracted by the second.
Now see,
A1.
understand.
Okay. Okay, because there are two. A1, A2.
Correct. And the heaviside function, when you have written a1, the heaviside function for this thing will be at a till a1 it is 0, and after a1 it becomes 1.
Yeah.
Okay. Similarly for this, till a2 it is 0, and after a2 it becomes 1.
1.
Okay. Now understand, as per this, a1 is actually less than a2.
A1 is less than A2. Yeah, because
So as per the number line, a1 comes on the left, a2 comes on the right.
Yeah.
Okay. So if you do it similar to what we did in this case, if you do it similarly, again the equal to sign is wrong. Okay. According to me, the equal to sign has to come over here, and the equal to sign has to come over here.
Yeah, I understood that.
Okay. So there is some printing mistake over here. Okay. But I hope
Yeah.
you understand how the heaviside function is used. Whenever the functions are split across terms, you can merge it together using the heaviside function.
Yeah.
Okay. So let's see how to apply this in a function. Let's see if it is shown over here. So you have f of t is t square, okay, from 0 to 2, and f of t is 6 at t greater than 2. Again, over here there has to be an equal to sign. Okay, they have not given it in the question, but there has to be an equal to sign, and therefore you'll see t square plus 6 minus t square into ut minus 2. Ut minus 2 is basically the heaviside function at the point 2. It is 0 for less than 2, and it is 1 when it is greater than equal to 2. Okay, and now you are just going to apply your usual what do we say, Laplace transform. Now in the Laplace transform, you can use linearity. You have the first term is simple, and the second term is where the heaviside function comes, and this is where you will probably be applying your, what will you apply? The second shifting property.
Second shifting. Yeah.
Okay, but second shifting will not be applicable directly. We'll come to that particular point. We'll come to that. So first let's focus. So for t square, it's a linearity property. The first term will be simply written as Laplace of t square. But for the second term, okay, see how it is written. You have t over here. Okay, now you wanted the function to be in t minus 2. Remember? If you go back,
yeah,
you
the
wanted
heaviside part, right?
Yeah, with the heaviside.
Minus a.
Whenever it was multiplied by the heaviside function,
you
wanted this function to be also in the same form, t minus a form.
Yes.
So since the heaviside function over here is t minus 2, you are expecting the function to be also in terms of t minus 2.
Yeah.
Okay. Now since you do not have a t minus 2 over here, okay, there are two ways of doing this. You can try to write this entirely in terms of t minus 2, and then replace that t minus 2 by t. Okay. Or
okay.
Instead of converting it into t minus 2, wherever you find t, you replace it by t plus 2.
Okay.
Do you understand what has happened?
Yeah. But so that's isn't that a little convenient here? If it was something else, t plus 2 wouldn't work, right?
Why? I did not understand. See, instead of whatever.
So if it was 6 minus.
Yeah. Go on.
Yeah. No, I was saying if it was 6 minus t cube instead, if we put t minus 2, t plus 2 in place of t, we won't get t minus 2 as the end of this thing, right?
No, I did not understand.
Okay, is this thing just to substitute that value there?
So, okay, so if you remember over here in the shifting formula, what happens is when you have f of t minus a over here, you are not taking t minus a in the Laplace transform. You're actually taking f of t.
Okay, right.
So I do not want t minus a. Actually,
yeah,
I am only looking at f of t.
Okay.
But okay, now let me just show you why these two are similar. Okay, let me just write this in terms of t minus 2. Okay, let me show you.
Okay.
6 minus t square. Okay, so this is your function.
Yeah.
But I want this in terms of t minus 2. So what will happen? Let's say that instead of t square, I'm writing t minus 2 the whole square. So what would be t minus 2 the whole square?
T square minus 4t minus plus 4.
T square minus 4t, that's correct. Plus 4. That is your t minus 2 the whole square. But I need a negative sign for t square because it's a negative sign. So I'll put a negative over here. This becomes plus 4. Sorry, plus 4, and this becomes minus 4. Is that correct so far? Now, actually, I do not have a 4t in my original expression. That means I have to subtract that 4t as well.
Yeah.
Okay, now when I am subtracting 4t, again, I cannot have a 4t part. Okay, I cannot have a t part. I need a t minus 2 part. Correct? So,
okay,
instead of just minus 4t, I'll write minus 4 into t minus 2, which becomes a plus 8, which I want.
Yeah.
Okay, so now I have a minus 4 plus 8, which is only plus 4 total. Whereas I need a plus 6. So I will add another plus 2. Now, is this expression same as 6 minus t square?
6 minus t square. Yes.
Okay, which now I'm actually writing as t minus 2 the whole square minus 4 into t minus 2
Oh, okay.
plus 2. Now, you can say that this is a function of t minus 2.
Yes.
Okay, now I need to change t minus 2 to t for my Laplace transform. Am I correct?
Yep.
Okay.
Yeah.
So my Laplace transform should be of minus t square.
Yeah. Minus 4t plus 2.
Minus 4t plus 2. This is what I am supposed to be doing the Laplace transform of. Is this clear so far?
Yeah.
Now let's see what
Yes,
I
sir.
got. Okay, just by replacing t by t plus 2, I got this.
Yeah.
Let's try to simplify this. 6 minus t plus 2 the whole square. Okay, 6 minus bracket t plus 2 the whole square. Let's simplify. What do I get? 6 minus, I'll keep the bracket as it is. Sorry. T plus 2 the whole square is t square.
T square plus 2t plus
4t,
4.
right?
Sorry, 4t, right?
Plus 4.
4.
Let me, okay, fine. So minus t square will be minus t square. I'm just opening the brackets, writing t
Yeah.
square first. Then the plus 4t becomes minus 4t.
Yeah.
And then I have 6 minus 4, which is as good as,
Plus 2.
are both the same.
Yeah.
Do you understand what happened?
Yes, sir.
Okay, so you want the function to be in terms of t minus 2. Okay, but what the simplification is, so what they could have written over here, okay, in the second shifting property, okay, just to make it more simpler, rather than having it in this form, control C, what could have been done, okay, they don't have the sign over here. This was your original function, correct? This is the
Yeah.
second shifting property which is given to you. Now,
Yeah.
the trick is, what you can do is, rather than having this, okay, you are probably doing this. Does that make sense?
Yeah.
Okay. This
So
is
wherever I need to get the t minus a term,
correct.
I substitute that value t for t plus a.
Correct. This is what they have
Okay.
done. Does, like, you have understood
Yeah.
how it happened, or have you understood that the
Yeah.
result remains the same? More importantly,
Yeah. Yeah.
okay. So if you want, you
Yes.
can just like note this, or take a picture of this. I can just zoom it if you want to click a picture. Okay, both of them are actually the same. Is it clear?
Yeah.
Okay, fine. Let's go on to the problem. So now what has happened? They have done 6 minus t plus 2 the whole square. Now from this step to this step, actually they have not solved. So what is happening is, you are expanding this. After expansion, you actually got
Yeah.
minus t square minus 4t plus 2. This e raised to minus 2s remains as it is. This is Laplace transform of t raised to n. Do you remember Laplace transform of t raised to n?
Raised to n. Yeah. It's n factorial upon s to the power n plus 1.
That's correct. So t raised to 2, 2 factorial upon s cube. So you get 2 by s cube. Then you had minus t square. So minus t square becomes minus 2 upon s cube. You had minus 4t, that is minus 4 into 1 factorial upon s square. And then you had a constant. Laplace transform of 1 is 1 by s. So you had over here
Yeah.
plus 2. So therefore you have plus 2 by s at the beginning. And this entire thing is multiplied by e raised to minus 2s, which is what you have before, like after applying the second shifting property. And that's your final answer. Is it clear?
Yeah.
Okay, let's proceed further. The second question, again, you have the, okay, so now the equal to sign is in the right position. Okay, this is the right position for the equal to signs. Okay, it's a t-step. So
Yeah.
you'll have two separate heavy side functions. You have t square plus 4
Yeah.
minus t square into u of t minus 2 minus, they have written, okay, it is 0 minus 4. So they have just written minus 4 over here times u into t minus 4. That is your second heavy side function. And they have simply solved it. So basically what has happened, t square, it's 2 by s cube. Over here, this heavy side function is 2. So they have replaced this t by t plus 2 the whole square, correct? And
Yeah.
after they have put t plus 2 the whole square, that becomes t square. Because it's a negative sign, minus t square minus 4t minus 4. So 4 and 4 gets cancelled. The negative sign has actually come out. Minus e raised to minus 2s. You have t square plus 4t. T square becomes 2 upon s cube. And 4t becomes 4 upon s square. and over here minus 4 into ut minus 4. Ut minus 4 second shifting property becomes e raised to minus 4s, and minus 4 the negative sign remains as it is, 4 becomes 4 over s, and that's how you get to your answer for this particular question. Is it clear?
Yeah. Yeah.
Shall we proceed?
Yes.
Okay, now this is where you have a 3-step function, and in this 3-step function again you are going to apply the two heavy side functions. One is ut minus 1,
Yeah.
the other is ut minus 2, and then they have just, so over here you have a t minus 1 along with t minus 1, so you can
Yeah.
replace t by t plus 1 and you will see that it becomes t as it is. Or
Yeah.
you have t minus a, so you can directly put t, which will be what the second shifting property actually says. Okay, and in the second function you see this is 2 minus t and this is t minus 2, so this is
Yeah.
as good as negative t minus 2,
Yeah.
which becomes
So do we
negative
take
t
a negative sign out?
t minus 2.
Yeah. No. So do we take like -1 common and we take it
You
out?
can do that, or even if you simply substitute t by t plus 2 in the
T.
bracket, you
Okay.
will get
Yeah.
negative t at the end. It does not
Yes.
matter.
Okay.
Okay, if you are doing it right,
Okay.
your final answer will match. Okay,
Got
so
it.
what they have done is, see, they have substituted t by t plus 1, and that will still, your plus 1 minus 1 gets cancelled, you get t.
T.
Again over here you substitute t plus 2, you get 2 and 2 will get cancelled, you will get negative t, which is what you expect,
Negative T.
and that's
Yeah.
how you get your answer. Clear?
Got it. Yes, sir.
Next, let's go on. Okay, so this is slide 58.
Question.
This is homework.
Yeah.
Second. Okay, where is it? Okay. Today we were supposed to do till slide 59. So the one more slide, I think. Okay, these are also homework.
Okay.
Okay. So how many questions?
Yeah.
Today I don't have more questions. So